Good morning. This session comes out of a series of phone conversations I had with about 10 farmers this summer who were seeing a lot of giant ragweed and had a lot of trouble controlling it. So the idea was to think about the biology of this species, why it's becoming more of a problem for both conventional and organic farmers, and then to begin to develop a strategy for managing it more effectively. So I'm going to spend a little bit of time setting us up with a context to develop a strategy for managing weeds that are particularly problematic, like giant ragweed and Palmer amaranth. And then we're going to look at the biology of this species, both in terms of its strengths and its weaknesses. And then I want to suggest some ways of looking at strategies to control it effectively. And we'll follow up at 10 o'clock in a session that Tom Franzen's going to lead, talking specifically about the challenges he's had on his farm and some of the ways he's thinking about managing it and your ideas about what you might do if you encounter this species. So the basic challenges of weed management are different for conventional and organic farmers, but they're serious now. So herbicide resistance is here. We're going to look at what that means for giant ragweed. Multiple resistances within populations are here. We'll look at what that means for giant ragweed. Off-site movement of herbicides in air and water is a concern. And if you're not fully dependent on chemicals, or if you're an organic producer, the incomplete control you get with cultivation is problematic with species like giant ragweed and Palmer amaranth that are really aggressive. And complications due to weather. It's difficult or impossible to get effective weed control when it's raining when you want to cultivate. So what I want to argue for today is that durable improvements in weed management are a function of understanding ecological principles and processes. We'll talk specifically what this means with regard to giant ragweed. You need to learn the life history characteristics of problematic weed species like giant ragweed, and then you need to carefully consider and compare your management options. So how do we begin to do that? I'm going to use this term, weed population dynamics, and basically, if you keep a bank account, you know how to do weed population dynamics. All right, so there's an equation here that says what you have in the field in front of you is a function of what you had plus the births minus the deaths plus the immigrants minus the emigrants. So if you have a bank account, your balance is a function of the credits and the debits. The revenue going in and the expenses going out are going to dictate what you have. So when you do population dynamics, you're not doing anything more complicated than that, okay? We have to keep track of what's going into the seed bank, or we have to look at the populations from year to year. But if you want to be successful in weed management, you have to think about whether the population is increasing or decreasing. So we'll come back to that in just a minute. All right, so when we talk about life history, for an annual weed like giant ragweed, basically we can break things into 4 categories of life stages. You have a seed bank. Some of those seeds are going to remain dormant in the soil. A fraction of them will germinate. They emerge and they become seedlings. You try to kill those seedlings. The ones that survive become adult reproductive plants, and they produce more seeds. And those seeds may or may not survive and get back into the seed bank. So that's the annual cycle that we go through every year if we have annual weeds. And managing that requires knowing when and where you can intervene in that cycle most effectively. So let's look specifically at the seed bank, which is the source of our infestation problems in most fields. Okay, so you got seeds in the soil, and they have a number of different fates. They can emerge as seedlings. They might stay in the seed bank because a high proportion of weeds are dormant and they can persist in the soil. Some of them in the soil are going to die. They're going to get attacked by pathogens, they're going to age out, or they're going to germinate at a depth in the soil from which they can't emerge successfully. And ecologists call that fatal germination. Okay, the ones that survive and emerge as seedlings may make it to adulthood, and if they're successful as adult plants and they don't get killed by cultivation or herbicides or other factors, they produce more seeds, and those head back into the soil seed bank. A certain percentage of them, as we'll talk about later, are eaten by birds, insects, and rodents like mice. All right, so that's a quick and dirty overview of the seed bank. So keep that in mind, because we'll come back to a number of those items. All right, so as a way to look at how this stuff can be operationalized, I want to talk about this species, giant ragweed, Ambrosia trifida. It's a native. Okay, so this is not a weed that came from somewhere else. This species is native to the Midwestern U.S., much of Canada, much of the East Coast. And like the name implies, it can get big, and it can be extremely competitive. Folks in Ohio, Indiana, and Illinois have been dealing with this species quite a bit, and they've published a survey of crop advisors recently that looked at how these folks, on a county-by-county basis, rated giant ragweed relative to other weeds that they're dealing with. And you can see here, the dark red color over here and in here represents the most difficult or one of the most difficult species that crop advisors are seeing on a county-by-county basis. So it's not trivial, right? And it's around, and as we'll be discussing in just a minute, it seems to be getting worse. All right, so why is this species successful? What are its strengths? And after we talk about the strengths, we're going to talk about the weaknesses, right? There's a reason you don't see it growing everywhere in the world around you. It either hasn't arrived there yet, or the habitat is not suitable, either because the physical and biological characteristics of the habitat don't work for that weed, or people are controlling it. So we'll look at the strengths, then we'll look at the weaknesses, and I think we'll come up with a set of strategies that may be useful in controlling it. All right, so if you're a conventional farmer, one of the things you're dealing with right now is that there are many populations of giant ragweed that are not only resistant to glyphosate, but they're also resistant to other herbicides, the ALS-inhibiting herbicides. All right. So you can see here populations of giant ragweed that are resistant to glyphosate or multiple herbicides or the ALS herbicides alone, and there's a lot of that going around. And that's not going to go away if people keep spraying glyphosate and ALS-inhibiting herbicides. So this turns into kind of a nightmare for conventional farmers who have been relying on these materials. So this is a field in Ontario that Peter Sikkema photographed, and you can see in corn, it's been overtopped by giant ragweed. In corn, it's being heavily competed against, right? And they report 82% corn yield loss on Ontario farms being sort of at the high end, but an average of 72% where they have these resistant populations. So this is not a trivial problem for conventional farmers. And you know, there are a variety of ways you can deal with the problem, but it is going to take a conscious attempt to develop an effective strategy. All right, so giant ragweed is a plant that has separate male and female flowers, and the male parts are up above, and the female parts are down below, similar to what you have in corn, except rather than just one ear, you have multiple seeds being set in these different bract areas here. All right? It produces a large seed, and those seeds have substantial energy reserves. Okay? So it's 10 millimeters, 25 millimeters is an inch, so it's the whole seed there, the whole seed structure is about a little less than half an inch. packed up with energy reserves and nutrients. What does that mean with regard to biology? It means that this species can emerge from greater depth than small-seeded species like water hemp and lamb's quarters. Okay? Large-seeded species have enough energy to push that shoot up to get to the soil surface from several inches below. Okay? So that's an important characteristic to keep in mind, that this species is ready to go even if you bury it. It has large cotyledons that are a function of having that large seed size, and these cotyledons are photosynthetic, obviously, they're green, and they start setting up that young seedling with more energy from the moment that it emerges out of the ground. So you're getting set up for a plant that is highly competitive. It devotes a lot of its biomass, dry matter production, to leaf production and height growth. So if you've seen this species, you see it gets very leafy quickly. It extends those internodes so it can gain height quickly. And what you've got is a species that can be fully capable of overtopping the crops with which it grows, be they corn or small grains. So here's a small grain field that David Weisberger photographed, and you can see that there's no way that they're going to get control of this. Another characteristic of giant ragweed is it's among the earliest emerging species that we have. So here's a set of results from late March to late June in terms of the emergence time of the common weeds we see in Iowa and Illinois. So giant ragweed is down here with kochia as one of the early emergers. It tolerates cold soil conditions quite well. And species like water hemp and redwood pigweed typically come up later, although you may get a few on the outside end of the curve. Lamb's quarters is fairly early as well. Common sunflower is pretty early. Common ragweed is pretty early. But giant ragweed and kochia are two of your earliest emerging species. Crabgrass comes up here pretty late. Fall panicum, pretty late. Lately, the emergence characteristics have been found to be shifting among populations. So if you go to an agricultural field, in the past, what you saw is most of giant ragweed came up in April. And if you looked at the field edges or floodplains or areas where giant ragweed is well established, you often find populations that grow from germinants in April. So you get this pulse of germination early on, then not much later. But what they're finding in the eastern Corn Belt and what seems to be happening in eastern Iowa right now is that you've got populations with extended germination. Okay, so all the way here into June. What does that mean? It means that if you could allow this population to emerge and then you killed them all with chemicals or tillage, you would be unlikely to find more that came up later. If you went at this population and you applied chemicals or used tillage to kill these early germinants, you've got all these coming up later. And they can infest your field. This is the situation that's becoming more common in the eastern Corn Belt. And this is the situation that's becoming more common in Iowa, which is why this weed is potentially becoming more problematic. So this is, again, from that same article by folks at Ohio State, and they're asking crop advisors to report how many months does germination extend over in different places. And you can see where there's red in the eastern Corn Belt here, you've got a 5-month period over which giant ragweed is emerging rather than this very narrow germination window that you might have in eastern Nebraska. So from east to west, you're seeing this shift in the germination and establishment characteristics of this population, which are going to mean that it's better adapted to surviving both chemicals and early season tillage. That's a problem. Extended periods of seedling emergence are going to make control of this weed more challenging. All right, so those are some of the reasons why giant ragweed is a success story in the weed community. There's some other things that are in there, but that gives you a flavor of why that species is so effective at dominating many of our crops, managed both chemically and organically. It does, however, have a number of vulnerabilities, and we'll talk about these in more detail. Those large seeds contain significant amounts of energy and nutrients that are highly desirable for things that eat them, like mice, beetles, and birds. Okay? They're in the same way that humans consume grain, other animals eat weed seeds. So you can see high rates of seed removal by organisms that eat these seeds. Relative to other weeds, it has a short lifetime of seeds in the soil seed bank. So ecologists would call this a transient seed bank rather than a persistent seed bank. And we'll look at some numbers in a minute. So if those seeds go into the soil, unlike pigweed, unlike water hemp, unlike lamb's quarters, unlike velvet leaf, these seeds don't last that long. Most of them die within several years. That's not true for many of the small-seeded broadleaf weeds that we have to contend with. The other factor that contributes a vulnerability to this species to control efforts is that it doesn't make a lot of seeds. So if you look at water hemp, if you look at Palmer amaranth, they may produce tens or hundreds of thousands of seeds per individual. And those seeds last a long time. If you look at giant ragweed, it produces thousands of seeds per individual. So an order of magnitude or two order of magnitude lower than species like water hemp, Palmer amaranth. So that means the contributions to the seed bank, the inputs to that seed bank are lower than for some of the other problematic species that we have. All right, so let's look at some of the details. Seed predators in Iowa consume lots of weed seeds, and the dominant species we have in Iowa are prairie deer mouse and field crickets. We have some beetles and some birds. The group at Ohio State has looked at seed predation over a period of months for giant ragweed seeds on the soil surface, and what you can see is between the time those seeds hit the surface in November and when you plant the following spring, about 60% of those seeds can be consumed. If you were to leave those seeds on the soil surface for 12 months, in this experiment they saw 88% of the seeds consumed. Okay, so the remaining seeds are a problem, but as one of the contributing factors regulating the population of giant ragweed that you might use to your advantage, seed predation is important, and leaving the seeds on the soil surface for as long as possible is desirable. So from the standpoint of when you till, the longer you delay tillage, the better for seed consumption by organisms that are already in the field. They're native. They do this to meet their caloric and nutrient needs. All right, I mentioned before that these seeds don't last as long as others in the soil seed bank. So this is, again, the Ohio State group reporting results from where they buried seeds at different depths in the soil, and they looked at the fate of those seeds over a 4-year period. So some of them emerge, many of them die, and the percentage in black is those that remain viable. And what you can see is by the third season, in the top 4 inches of soil, the top 10 centimeters, about 90% of the seeds have died that were buried in the soil. There is persistence of some seeds, and as you go deeper in the soil, more of those seeds survive. So deep burial will prevent seeds from shooting up to produce new seedlings, but it also means that were you to till that ground again and bring those seeds back to the surface, a certain percentage of them, those shown here in black, will reinfest your field. But notice here that these white bars represent how many of the original seeds that were placed in the soil died. And in about 2 years, you can lose up to 90% of the seeds in the surface soil layers. Another characteristic that's potentially to your advantage as a manager of giant ragweed is that a very high percentage of the seeds that are going to germinate do so within 2 years. All right, so what these curves show you is for seeds buried at different depths, large seeds and small seeds, within 2 or 3 years, almost all of the seeds that could germinate have germinated. So the seed bank is not persistent in the sense of they go in there and 10 years down the line they're still capable of germinating. These seeds, if they're going to emerge, typically emerge in 2 or 3 years. So taken together in terms of the emerged seedlings and the seeds that died in the soil seed bank, about 90% of the giant ragweed buried in the top 10 centimeters or 4 inches of soil were eliminated in this experiment after 2 years. All right, we talked a little bit about seed production. So this is work that was done at the University of Minnesota. And this is looking at the number of viable seeds produced by giant ragweed on a field edge where it has to compete with other plants, and with giant ragweed growing in a soybean field, you can see it produces about 1,400 seeds per plant in that soybean field. That sounds like a lot. It is a lot, but relative to other weeds, it's a small number. All right, when are those seeds dispersed? Well, in this work done in Ohio, they found that the seeds started to be dispersed in September and ran into November. Okay? So that basically means that for many fields, the seeds are not ripened and ready to disperse until the latter part of the summer or into the fall. And that can be important in terms of your choice of crops, when you want to plant and when you want to harvest, to prevent seed production. So, yeah.
Does that depend upon when it emerged?
Yeah.
The emergence date relative to the viable seed?
Okay, so what you have here is giant ragweed that emerged with corn and giant ragweed in the black dots that emerged 4 weeks later. It takes a little while to catch up, but it eventually catches up. So the later it emerges, the later it produces seed. All right, so that's a very brief overview of the biology and ecology. Now we're going to look at management options, okay? So I want to start with some numbers that are intended to sort of scare you. All right, so this is what we're going to look at. We'll do a situation analysis. So the group up at the University of Minnesota went and took soil cores out of a field, and they used this spatially referenced information to look at the densities of giant ragweed in this field that had been used for corn and soybean production. So these are the number of seeds per square meter. Green is you're down here in the area of, say, less than 30. This area over here, you're in the neighborhood of 100 seeds per square meter. Does that sound like a lot or a little? Okay. Keep that in mind. That's 400 and some thousand seeds per acre in the seed bank. All right, we had a session yesterday talking about various approaches for managing weeds in agronomic row crops. So how many seedlings do you think you can kill? Less than all of them. All right, so just to give you a flavor of what's out there in the scientific literature, this is for multiple passes with a rotary hoe and multiple passes for an inter-row cultivator. And they range from 68% to 92%. All right, what we heard yesterday was some people are using up to 3 passes with a rotary hoe or a harrow, pre and post emergence of the crops, and 3 or more cultivations between rows, healing them up, right? So you get better control as you go through the field more often, but weather, of course, is always a potential threat to being able to do that in a timely fashion. And if you look at your control efficacy over years, I think you're going to have a hard time, on average, doing better than about 90%. So it can be hard to beat the numbers. So let's just do a back-of-the-envelope calculation. You got 100 seeds per square meter in the soil. That's 400 and some thousand seeds per acre. About 30% of those seeds might germinate and emerge. Might be less, a little bit less, but let's, for the purposes of this calculation, say 30% of them are going to come up. That's 120,000 seedlings per acre. You're good at cultivating. Most years you do pretty well. Some years you don't do as well. You got 90% control efficacy with cultivation. You've gone over that field multiple times. You've got 12,000 seedlings turning into plants per acre. Each one of those has the potential of producing 1,400 seeds. That's 16 million plus seeds produced per acre, pushing 17 million. Okay, we've got some hungry seed predators. They take 60% of the seeds by the time you want to plant your crops next spring. That means you're only putting in 6.7 million seeds per acre into the soil seed bank. Does that leave you feeling a little bit anxious? It might. All right, so let's look at some options for control. And we'll build this out from the idea of looking at cropping systems and the associated weed management practices that go with them, and evaluate our options. We could do this, we could do that. So I want you to consider 2 types of crops, okay? We've got row crops that can be cultivated, sprayed, or hand-weeded, but you're pretty sure that control is going to be less than 100%. How good it's going to be, we can adjust, we can do some things differently, but it's likely not to be 100%. All right, then you've got solid seeded crops that are harvested in midsummer, that are mowed or removed for fodder. So if you cut these crops, harvest them in a timely manner, you can prevent reproduction by giant ragweed. So let's look at what some of those options might be. Here's a winter cereal crop. In this case, it was triticale. Drilled directly into soybean residue. You wind up with a lot of winter cover. That winter cover can be highly competitive with giant ragweed that's trying to emerge in the spring because those roots and those shoots are already in place, and they modify the soil environment with regard to temperature. They take nutrients, light, and water, and they're quite competitive against giant ragweed. So this crop of triticale that was grown from fall-planted seed is maturing when corn is still green. Obviously, in the middle of the summer, this crop is going to come out. It's cut, in this case, direct combined, and the giant ragweed that might have been growing with it would be cut off. If you have a severe infestation, like I showed you in that picture early in the talk, this isn't going to be possible, right? And we'll talk more about what that means. But cutting this crop in midsummer effectively prevents giant ragweed from completing its life cycle and adding seeds to the soil seed bank. You also have the option with hay crops of cutting them multiple times, and that can be extremely effective for preventing giant ragweed from going to seed. And remember that those seeds are only going to last in the soil seed bank a couple of years. So if you have an established crop of hay for several years, many, but not all, of those seeds can be taken out of the seed bank. All right, so if you want to develop an analysis of management options, here are some of the questions you might think about. And here are some of the questions we're going to try to answer right now. How good does weed control need to be to keep the population from increasing from year to year? What's the length of a crop sequence that contributes most effectively to control? Is the sequence of crops, row crops and solid seeded crops, important, or can you fit them in however you want? And if you are going to use hand weeding, is that an effective supplement to cultivation? So when I look at options, I don't have the luxury of doing field experiments to test every option that I want to consider. They're expensive, they take time, they take space. So I rely on data generated by my colleagues in other universities, some of which I generate myself, to go into a model like this and look at these processes: seedling survival, seed production, new seed survival, seedling recruitment, germination, seed bank survival. Okay, if I can get numbers like I showed you earlier, I can plug them into a model. And then I can look at how different options like cultivation, mowing, herbicides, crop competition, seed predation, seed decay, tillage, all affect the population dynamics. And I build models to do this. And when you evaluate the outcome or the output of those models for population dynamics, you look at what's happening to the seed bank, and you look at the number of plants that are infesting your crops. All right, so that's what we're going to do for the next couple of minutes. So here's a 3-year rotation where we have a solid seeded crop, then we have row crops, and I asked the question, how good does the control efficacy of giant ragweed have to be in the row crops if I get 100% control in the solid seeded crop? Okay, so I've got a solid seeded crop where I'm mowing it, or I'm cutting it in midsummer. None of those giant ragweed that came up are able to produce seed, but the ones that came up in my row crops have the opportunity to survive at various levels. So I ran the model, and what you see here is over time, the population is building up. In the model that I built, I have what's called density dependence, right? These populations can't grow infinitely large because there's a carrying capacity. You can only tolerate so many plants before they start competing with each other and limiting their growth and seed production. So there's kind of a limit to the size of the population that's 20 per square meter, or about 20 per square yard. So this is a result of different levels of control efficacy in the row crops. And what you see here is that even 95% control efficacy is not good enough, that these populations, all of them, go up. But we can keep running the model and we can figure out how good weed control needs to be. So here's a 3-year rotation with a solid seeded crop at the start with 100% control efficacy of giant ragweed. And when you get to 96.3%, those populations start coming down. The seed bank is in red. The number of mature plants in your row crops is in blue. Okay, so above 96.3%, if you've got this solid seeded crop in your rotation, you've got control over the longer term. So that's hopeful. But 96.3% is not necessarily an easy number to get to. Is the length of the rotation important? All right, so here, what I've done is I've compared a 3-year rotation with the solid seeded crop and 2 row crops, and two years of solid seeded crops and 2 row crops in a 4-year rotation. So this is the level of control based on those kind of model outputs I just showed you that you need to prevent weed population increase. And in that 3-year system, you needed 96.3% control. If you go to that 4-year system with the 2 solid seeded crops ahead of the 2 row crops, you only need 90.2% control efficacy in your row crops. So having 2 years of this solid seeded crop ahead of the 2 row crops means that your control doesn't have to be as good in the row crops. That's helpful. Is the sequence of crops important? So I've gone into that 4-year rotation. I've got 100 seeds per square meter in the soil seed bank. Is it better to start out with 2 years of the solid seeded crop where I've got very effective control, followed by 2 years of row crops? Or is it better to go into the row crops and then follow that with the solid seeded crops? If you do the former, you can get away with 90.2% control, and the population is going to go down. If you do the latter, where you've got the row crops where you have less than perfect control, followed by the solid seeded crops, you need about 98% control. Which would you rather do? If you have the option, I would start with the solid seeded crops first and deplete the seed bank because the seeds in the soil don't live that long. Okay, the final scenario we want to evaluate is what happens if you're able to supplement cultivating with walking the crops and hand weeding. How good does that hand weeding have to be? So the first scenario that we're evaluating in this row crop scenario, you've got 90.2% cultivation efficacy, and above, you don't need hand weeding to control the population. If you want to use hand weeding, you could drop to 80% control and supplement that with about 51% of the plants that survive are pulled out by hand. So you're not going to get them all, but if you can get about half of them, your cultivation efficacy could drop to 80%. So it's definitely worth walking your crops if you have less than perfect control with herbicides or cultivation. So these are ways to evaluate your options. They're based on what you would do if you developed a pro forma for your business plan, right? You project revenue, you project your expenses, and you look what would happen. You might want to evaluate what happens with some variation in the revenue, some variation in expenses, to understand how your business or how your weed management plan might be more or less resilient to bumps in the road. All right, so here are the key points. Minimize seed inputs. Start new rotation sequences with weed suppressive crops and effective control practices. When you're moving from what you're doing now to what you're going to do next, front load your weed control with species like giant ragweed that do not have persistent seed banks, because all that time that you're suppressing the input of new seeds, seeds in the soil seed bank are decomposing and decreasing the number of problems you're going to have in the future. So you want to deplete the weed seed bank by allowing seedling emergence while preventing reproduction, and you want to encourage weed seed predation by leaving seeds on the soil surface as long as possible. So there are lots of other options. These are just some things to consider and to get the conversation going. Thank you. Yes, ma'am.
On that spatial diagram that you had,
Yeah.
what was the scale? Was that one plant there in the center, or was it like
No, it's a big field.
a crowd of plants? It was a big field?
It was a big field, yeah. Multi-acre, like probably 10 to 20 acres. So, you know, weeds occur in patches, we know that.
Sometimes it's because that's the wetter area of the field where the crops flood out with some frequency and the weeds are able to build up a seed bank. There's some other reasons, right? But the point of this is that there's a pretty large area of this field where those weeds are relatively abundant in the seed bank. And for most of our common weeds, that's the case. And you need to, like when we did that situation analysis, you need to take a cold, hard look at what the implications are of having your seed bank fully loaded when you start your weed control, okay? So weed control is not for the weak of heart. Tom.
With the energy in the ragweed seed, it has a lot of energy. What actually all goes on in the soil biology that causes that to degrade more quickly than like with a velvet leaf seed that may have less energy in it because of its size? I actually have two questions for you on seeds. Let's start with that one.
Yeah, so the question is, if you have a large seed like giant ragweed has, why does it decompose as rapidly as it does relative to other large-seeded species like velvet leaf? I don't have an easy answer. I think Adam can speak to that more directly because he's looked at that. Giant ragweed probably does not have a real hard seed coat relative to velvet leaf. So velvet leaf has a relatively impermeable, gas-restricting seed coat, and it has to be cracked before those seeds are capable of germinating, and basically when they crack, they're much more susceptible to pathogen attack. And I don't think giant ragweed has any kind of, it has an outer structure, but you probably have looked at degradation of seed coats, and it might be a little more susceptible to degradation. Is that true? Okay. Mm-hmm. So one of the things to know is that seeds are alive, and they respire, and there's a lot of biochemistry taking place there. They slow down when they're dormant, but they're not dead. And some seeds have higher metabolic rates, and that allows them to be, I'll say, they age more quickly. And giant ragweed may be one of those, where the metabolic rate is relatively high, and the aging process takes place relatively quickly, and a certain percentage of those seeds definitely survive for a long period of time. So don't think because 90% of them decompose, you're out of the problem, because a small percentage of a very big number is still a big number, right? So. Okay, so the question is, if you were to cut off a giant ragweed plant where the seeds are maturing but not quite mature yet, what's the fate of those seeds? So most weeds continue to mature even though you've severed them. And seeds can start out at some not fully developed point, and even though the shoot is not attached to the ground, those seeds can continue to mature. So obviously the earlier you cut them, the less chance you have of those seeds maturing. But if you cut them late and you leave them in the field, a certain percentage of them will produce mature, viable seed. So some farmers that I know will actually haul the weeds out of the field if there are not too many of them.
Also, some weeds have different characteristics. Now, a giant ragweed, if you cut the top off of that, it won't produce any more seed after on that plant, will it? Some other weeds have that ability, right?
Yeah, I mean, what you're worrying about is the branching characteristics of weeds, right? And giant ragweed can branch, and I won't tell you that it won't, but relative to species like lamb's quarters, which you can clip and will send out shoots that run around the ground and then produce a lot of seed, it's not like that. It's more like velvet leaf where the emerged shoot is easier to control. But yeah, I mean, you need effective crop competition or some other means of control to prevent a plant that you've just cut off from producing branches and producing more shoots. You'll delay the production of seed, but you won't eliminate it unless you get it out of the ground. Here. What would I do in a woodland area? So the question is, if you're on a field border or a woodland area that abuts the field, how do you deal with those giant ragweeds relative to your management plan for the field? So the first thing I would think about is those are important sources of seed to infest the field, and you want to prevent that from happening. You either have to mow it, you have to plant something there that's competitive and mow that, or you have to in some way kill them chemically or, you know. But field edges are often infested in my experience. I mean, my introduction to giant ragweed was what grew in the hedgerow. And as we're seeing, those plants tend to emerge early, synchronously, and that allows you to think about a control strategy that's focused in the early summer through mowing or some other means of control. But I definitely would not let those plants go to seed because they're going to move. Laura.
Well, another option could be if you didn't, if you wanted to convert that woodland to herbaceous perennial vegetation, right?
Mm-hmm.
If you had perennial grasses in there, they would compete effectively with your giant ragweed compared to the trees.
Yeah.
Where there's more bare ground, there's more opportunity for that ragweed to survive
Right.
inside a woodland than it would in either, row or orchard grass or prairie. The ragweed would not be there.
Yeah, it is worth considering, though, that the first wave of ecological studies that were done on giant ragweed were to answer, why is this plant so dominant in communities? And, they started looking at cold tolerance for germination and seedling growth, high rates of photosynthesis, the ability to get taller than everything else there. And, it's a very competitive plant on field edges as well, as you're well aware. So you do have to make a conscious effort at control if you have a well-established population there. And by well-established, I mean that the seed bank is loaded up and can provide enough germination and emergence every year to replenish that seed bank. So if you don't intervene, I think you're likely to have a continuing problem, and ultimately that is going to serve as a source of seeds that are going to migrate into the field. Adam. Comments, questions from somebody else? Paul. Yeah, I mean, that effectively is what that solid seeded crop is doing. Yeah, and if you mow it several times per year, you will effectively eliminate seed production. The question is, what proportion of the seeds in the soil persist? And the deeper they are in the soil, the more of them will survive. So if you have an infestation, keep them close to the soil surface and mow frequently. Fred?
What that raises for me, I mean, and I understand this from my own point, treating with alfalfa is critical. What are you going to do with the alfalfa? And sometimes if there's a drought in part of the country, you can get really good money for the alfalfa and it works out okay economically. Other times you can't even sell it.
Yeah. Yeah, agreed.
Marketing system has for 100 years been focused primarily on specialization because the people who are making the money on that want to make it on what's going to be the most money. And
Yeah.
so that's been what drives the
Yeah.
cultures and creates the problem that we're trying to solve.
So if you didn't hear all that, I'll try to briefly paraphrase it, which is that solid seeded crops appear to be important components of developing a ragweed management plan. The question is, what do you do with those solid seeded crops if you're not feeding them directly? Where can you sell them, or what can you do with them? And that, I mean, I don't have an answer. Fred doesn't have an answer. Tom?
Yeah, I've been battling this for a long time, but one of the strategies I use is to make silage. We got a beef cow herd. It's not a bad silage, and you get it before it goes to seed. But without a cow herd, you really are really hamstrung. But Laura Jackson was able to give me some kernza, and we planted kernza on 1 acre that has a very heavy giant ragweed pressure in the fall of 2014. And in the summer of 2015, we shredded the kernza off with a fair amount of ragweed in it, middle summer, then it grew back. In 2016, there was no giant ragweed in the kernza plot.
Yeah, so for those of you who don't know what kernza is, it's intermediate wheatgrass that's being developed as a grain, a perennial wheat substitute. So obviously if you have a competitive crop that's being cut at a time when giant ragweed is prevented from going to seed, it can be part of your control strategy. Yeah. So, you know, another issue, when I say solid seeded crops, I don't necessarily mean multi-year stands of forages. If you can work with fall seeded cereals like triticale or winter wheat, you do have the option of having a very competitive grain. I won't say that your giant ragweed won't be a problem, but it'll be a lot less of a problem than if you plant oats, spring barley, or spring wheat, because you plant a spring grain into a field that has a high amount of giant ragweed, you have all that ragweed emerging with your grain. What are you going to do? You can't cultivate it. If you're a conventional farmer, you can look at some herbicides, phenoxys like 2,4-D, whatever, and take it out. But if you're not going to do that, you have a highly competitive weed in a crop that's not cultivated, and you have a serious challenge. So Tom has ensiled it or fed it after he's chopped it. But if you want to go all the way to grain, you know, you have to start thinking about, do I want to swathe it? Do I have a lot of problems when I direct cut it? So be careful with spring grain in fields that have a high population of giant ragweed. You may not be happy with the result. George?
Well, that doesn't happen to be my problem wheat, so would you recommend a resource where if I have wheat X, I will learn practices that will combat that wheat, like online?
There are some online resources to learn the biology of your weeds. I think careful observation yourself can probably tell you a lot. And so you want to think about the timing of emergence, which species come up early and which species come up late. And Iowa State has some good resources for emergence timing. So you can begin to think about sequencing your crops to miss the peak or to interfere with the life cycles based on emergence timing. So one place to look is at Iowa State. You know, they're basically different groups of weed species with regard to how long seeds last in the soil. The general rule is that annual grasses, like giant foxtail, yellow foxtail, woolly cupgrass, don't last more than several years. And that broadleaf weed species, with the exception of giant ragweed and one or two others, tend to last a long time. So things like velvet leaf, water hemp, lamb's quarters are persistent. Persistent species are obviously more trouble. Okay, what percentage of them come up in the seed bank, from the seed bank? It varies among species. And that information is a little more difficult to come by, and I can help you find some of it. How many seeds do they produce? Well, the general rule is a lot. So make your assumption that you have ample seed production, and anything you can do through crop competition, narrower spacings, more rapid emergence, canopy closure, selection of more competitive cultivars increases the competitive ability of the crop and reduces the amount of seed set. But where you have weeds, you have seed. Okay, so what can you do about the seeds that are set? Delay tillage as long as possible, provide habitat for things that eat, and forage for those weed seeds. So if you have seed production, leave those seeds on the soil surface for as long as possible. If you're going into a highly competitive crop with a lot of weed control options, maybe let those seeds stay on the soil surface and do some direct drilling or shallow tillage. If you're not going into a competitive crop, think about burying those seeds with deep tillage and leave them down there for a while. They won't all die, but a certain percentage of them will die. Here, Roger.
I have a flamer sitting in the shed, and right now today we have highly saturated. I got a lot of weeds out in my field the way it sounds. So they're laying there on the top of the ground. And I think some research has been done with flaming weed seeds, and if not, they don't think it has an effect. But I was thinking if you had a frozen seed that was saturated with moisture, and then all of a sudden you shocked it with 1100-degree temperature, would that have some kind of an exploding effect or some kind of a termination on
So,
I could be out there flaming today with a lot less risk of starting.
yeah, absolutely. So the thing to understand about flaming is that you don't typically burn things up. What you do is you disrupt membranes. Okay? So the reason flaming is effective on growing plants is not because you incinerate them necessarily, unless you want to use a lot of gas, but you disrupt the membranes and you get denaturation of proteins, and the plant will effectively die because of that damage, not because of the burn. But I don't know what would happen if you were to heat a fully imbibed seed. You know, obviously those seeds are alive; they're potentially dormant, and many seeds are equipped with seed coats that resist the kind of heating damage that you might incur. But I mean, you could do a strip and see, right?
Switchgrass, I think part of the protocol for getting established switchgrass is to burn it to help the seed do something. So one part of my question is, I'm guessing some seeds need to be, have some sort of a fire that promotes the growth of that plant.
Yeah, certainly in a lot of forests, that's true. I don't know about prairie seeds, but yeah, there's certainly like a number of conifers that respond to burning. In fact, some of them are biologically engineered to only produce seedlings after a burn. So you could do a strip. I mean, that could be an on-farm trial, just side by side, go across your field now, or, you know, when it's still relatively moist and you don't have a danger of setting things on fire, and see what happens. See if you get differences in emergence. Go out and build yourself some quadrats and throw them down, 10 over here and 10 over there, and make a comparison and see if you get any control. Laura.
Oh, I was just going to say, you know, when you burn prairies, it's more stimulating the living plants. It's not the seeds. Also, if you look at the soil temperature just below the surface, it's cool. So you could kill seeds right at the surface, but especially in the moist soil, any kind of moisture, it's a great insulator. So the seeds that are even just a tiny bit below that surface will not be affected by that flame.
Adam. So the idea there is you can actually inject it in the planting row. You, so obviously, you know, you don't want to use all that energy to produce all that steam for the whole field. But if you can do it right where you're going to plant for a high-value crop, and they've been doing it for sugar beet and a few other vegetable crops in Denmark. Yeah. Yeah, no, that's true. Adam's been doing work on grinding seeds. So work in Australia has been developed with attachments on the harvesting equipment. And older combines that I'm familiar with actually collected the weed seed. So the idea would be that rather than dispersing that seed back onto the field, you actually grind it up and turn it into a powder. So you can maybe visit with Adam here. And there's some commercial firms that are now thinking about dealing with the herbicide resistance problems in weeds by mechanically destroying the seeds. And that's certainly a strategy that organic farmers. So you can think about that as a mechanical seed predator, right? And you know, from the standpoint of the biology, it functions the same way. The adult plant is picked up before it's dispersed all that seed. It goes through the harvester. Those seeds are separated from your crop seeds, and then they're destroyed before they're added back to the soil seed bank. And that has, over a period of years, a pretty effective driving force on the seed bank. When you drive that seed bank down, the number of seedlings you have to kill through cultivation or other means is reduced, and that's what we're looking for. Getting higher and higher levels of control, lower and lower levels of seeds going back into the soils. Yeah.
Is there documentation of ragweed resistance to the 2,4-Ds?
Probably, I haven't looked, but you know, if you have populations that have been exposed over a longer period of time, I would expect somewhere. But there's a excellent database run by Ian Heap at Oregon State called weedscience.org, weedscience.net. You can look up every case of herbicide resistance in the world. So you can find out where it's been recorded, to what groups of herbicides this particular set of populations is resistant. The general rule is long periods of exposure tend to generate resistance. And you know, the question is giant ragweed that we have now different from the giant ragweed that we used to have? And there's some indications with the changes in emergence timing that these populations are evolving. And you know, if they can evolve resistance to ALS inhibitors as well as glyphosate, I would expect that there's a population somewhere that has resistance to phenoxy herbicides.
Can I ask a following question?
Yeah.
to that? If you drive around the country, a lot of times you'll notice that there's a ragweed pressure in the fence rows and the ditches. And the field had been sprayed, but then the spraying, let's get to my chores. But then it didn't control all of it, and then it controlled less and less. I wonder if that's not a way that...
Yeah, maybe a dose response too. You know, the stuff on the edges are subjected to lower doses. But yeah, I mean, we have resistance in giant ragweed. That's not going to go away. Yeah. Right. Yeah. So, yeah, as long as those weeds are emerging early, that burn down will be extremely effective. As you get a change in the population dynamics towards genotypes that are going to emerge later and later, or you get this dispersed emergence pattern, then that burn down may be less effective. You know, the residual will be wearing off, and you may find them coming up a bit later. Obviously, the ones that are later are less competitive with your crop and produce less seed. Yeah. Yeah. Wendy. So the question and comment were that burn down generally works, but you find it in where water is running. Is that right? Yeah, so seeds do disperse on the soil surface in running water. So that's fully possible. You could be moving them in or around the field where water runs. And I mean, that's you can get fairly long distance dispersal across fields by paths of water running after seeds have been dispersed on the soil surface. So you may be seeing that. How do they do well? Weeds are amazing, right? George, one more question.
We had luck with the crimped rye
Mm-hmm.
and soybeans as far as like water hemp.
Yeah, so
Did that work for this?
probably not. So water hemp is a very small seed relative to giant ragweed, and I would expect as the spectrum of weeds that you have larger and larger seeds, you'll get less and less control. I won't say it won't do anything, but giant ragweed has the reserves that if it's given a germination cue in terms of temperature, light, whatever, it'll push right through a lot of thatch. All right? I think they're running us out of here. Thank you all.